Hello everyone. For this tutorial video, I like to discuss line integrals of vector fields. And this is why I introduced vector fields at this point, because we use line integrals to compute values of them as well. Formally defined, the line integral of the dot product of a vector field function and the change in the curve you're integrating along equals the integral from point A to point B of the vector field of the line times the derivative of the line with the parameter t as the input, all this integrated with respect to the parameter t. If we integrate with respect to arc length instead, the derivative vector or tangent vector becomes a unit tangent instead, which we remember we derived earlier with the symbol capital T. We can confirm that this is equal to another definition given by first rewriting arc length as the magnitude of the tangent vector times change in the parameter, and then giving the full definition of the unit tangent instead of the symbol capital T. We see that the magnitudes cancel algebraically, and we get the definition we got earlier exactly in terms of the parameter t rather than arc length. So example, if we are told to evaluate this integral along this curve, and we are given specific limits for the parameter of the curve t of 0 and 1, we would first rewrite the vector field in terms of the parameter t, take the derivative, and then finally compute the dot product of this derivative in the original vector field, but in terms of t instead of the original problem given. So we now simply compute the integral from 0 to 1 as well as the limits of t given of this dot product simplified with respect to change in parameter. And after we do this, using calculus 1 techniques for integrals, we get a final answer of 1. Now that we've seen how line integrals can be used for vector fields as well as normal multivariable functions, we can give the fundamental theorem of calculus in terms of line integrals instead of single variable integrals. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.